Mr. Beak's math class. Mr. Beak's math class. Yeah! Woo!
All right, welcome to math class. My name is Mr. Beak, your wonderful host. Let's talk about some stuff, all right? Today, we got an exciting lesson on the distributive property. There's a couple math things for it. Let's look at some real examples. And hopefully, by the end of the day, you can say, I can simplify expressions using the distributive property. That's always the goal, okay? Before we do that, let's talk about an example. This is a real-life example. I like to make desserts. I'm kind of a sweet tooth. I have a penchant for eating stuff. And so this is something that I actually made from scratch. It's called the S'mores Brownie Supreme. And so it has graham crackers with brownies with marshmallows on top. It was the best thing ever. But unfortunately, I couldn't eat it myself. I had to share it with my whole family. Had to be nice to my wife and my little daughter Ellie and my son Landon. And so I drew up a little pictures. This is what they look like in circle form. All right, so when I made this dessert, yes, I wanted to eat it myself, but I thought I'd share some. And so I ate some, my wife ate some, my daughter ate some, and my son ate some. We all got it. That's the moral of the story with distributive property, is whatever you're distributing goes to everyone. And so they get it. So let's take a look at some math examples, okay? This is what it looks like in math form. And so this 5, it has to go to the x and to the 8. And when I draw these little things, it means I'm multiplying each one of those pieces. So the final answer is going to be 5x plus 40, because 5 times 8 and 5 times x. Not too complicated, and hopefully kind of that makes sense. So let's just kind of pound through a couple examples. This one right here is going to be the negative 4 times x and negative 4 times 3, which is actually going to be negative 12. Some people say minus 12. I say negative 12. It's all part of the what you need, all right? So does that make sense to everyone? All right, let's take a look at a couple more problems. And so when we do that, what are we going to get for all these guys? Well, negative 7 times negative 5 is going to be something, but we got to do this one first. It's going to be negative 7x, and then negative 7 times negative 5 gives me a positive 35. As simple as that, okay? Next one. Oh no, we add some numbers there. No big deal. Negative 3 times negative 6 is positive 18x. Negative 3 times 7 is minus 21. That's the gist of the distributive property, okay? We're going to be spending more time on that, but hopefully that makes sense. Next thing I want to talk about is combining like terms, all right? And like terms, if you take a look at this picture here, and you just say, all right, what are the like terms? These ones are 4x and negative 9x, because they're the same. 8 and 14, they're just regular numbers. 3x squared and negative 7x squared, they're like, okay? So those ones we could smush together. The non-like terms are these ones over here, where negative 6 and 8, well, the one has the x, so it's not like, okay? So just kind of let your eyes do the check in there. If they have different things, they're not the same, okay? So let's take a look at a couple problems. I like to think of it as an example of something like this. If I had 2 basketballs, so just pretend this 2 basketballs, and I had 3 footballs. Right now, do I have 5 basketballs? No, I have 2 of them, right? And do I have 5 footballs? No, I have 3 of those. Those things are not like terms. So I cannot combine those. I have simply 2 of the one thing and 3 of the other, right? If I scroll this down and now I say, all right, pretend I still had that same, the 2 basketballs plus 3 footballs, but let's say I added another 8 basketballs and I minused 1 football. Well, now these ones are alike. This 2 basketballs and the 8 basketballs can smush together, and I would say I have 10, I'll just say BB, 10 basketballs, right? And if I have the 3 footballs and I take away 1, or 1 gets popped or something like that, I still have 2 footballs. Okay, so that's how the combining like terms idea works. Well, now let me just say that instead of using basketballs, I put an x there or something like that. 2x plus 8x, right? And let's say under this green one, I put a plus 3 and a minus 1. Well, I can combine the two x's in the same way I can here, and I would have 10 x's. And over here, I'd have plus 2, right? And so that's going to be our math stuff, if you can just think about them as some are x's and some are y's, okay? Or some are numbers. They're either alike or not alike. All right, a couple practice problems real quick. Let's just give a few a shot and we'll call it good. First off, ask yourself, are those like terms? Yes, they are. How many of them do you have? Well, I have 9 of them plus 17 of them. If my math serves me right, that's 16 of them. Perfect. Any like terms here? Yes, there are. There's 13 r's and minus 6 r's. Notice this minus goes with that, right? It's not a minus 5. So 13 minus 6 gives me 7r. And then I just have that plus 5 left over, okay? When I do this, I like to underline or box, or, you know, some people put a box around it. Some people put circles around it. Some people underline. Whatever organizational pattern works the best for you, just do it that way all the time, okay? How about we expand this a little bit more? Oh no, there's lots of stuff. No big deal. Let's smush them together. Combine like terms. I have negative 8a and I have minus a. Well, really that means there's a 1a. So I have negative 8 minus 1 more is negative 9a. And here I have negative 16 plus 13 is going to give me a minus 3. Okay? If someone were to write plus a negative 3, would they be correct? Yes, they would. It just kind of looks weird. And so generally we're going to just write in math now, moving on, we're going to write just a minus sign. Okay? But regardless, that's how we do those. So we do one more. Let's just do one more. We'll call it good after this. Okay? What do we do first there? Let's think about this. PEMDAS, remember that? Please excuse my dear Aunt Sally. It says parentheses is first. So we always have to distribute first. In this case, we're going to distribute the 7 to the x and the 5. Okay? Just that is an isolated problem. Is 7x plus 35. That's no big deal. But then what happens is this 3, it just drops down because I didn't touch it. So it's going to be this. And now we have to combine like terms, which therefore, those guys are the same. Final answer, 7x, I'm going to write that first. But negative 3 plus 35, if you don't know, just punch it on your calculator, but it's going to give you plus 32. And I've combined my like terms, and I'm feeling good about my answer, so we're calling it good. Okay? Now, hopefully those things kind of make sense to you. Should be a little bit of review. We're going to do one last thing, constants, coefficients, and number of terms. Okay? And so you always just have to ask yourself those questions. Sorry about this. Let me get this all figured out. All right. The coefficients. Coefficients are the, maybe that should say variable. Anyways, constants. Constants are the plain numbers. So in this case, 4 is our plain number. The coefficients, we have an x and a y, another y, and another x. So we have 2 of those. We have an x and a y. Okay? Anyways, a number of terms. If I were to combine some of these, I probably should have done the same color. Let's do blue for these x's so I don't confuse it. Sorry about that. Negative 5x plus 2x is going to give me negative 3x. The y's are going to smush together to give me minus 5y, and then I have a plus 4. Well, each one of these things is called a term, and it looks to me like that there's 3 things there, so there's 3 terms. Okay? Hopefully those are making sense to you. I believe we're going to call that a day for a lesson. Talk to you later. Take care.
Mr. Beak's math class. Mr. Beak's math class.